Hello, everyone. Welcome to another episode of the Data Sense podcast. This is the show where you learn from technical and business leaders how to connect business and data to develop your own ability or sense to use data to drive your business forward. Today, we have Dr. Ankit Desai. Dr. Ankit is a director of data science at Locus.sh. He holds a PhD in distributed systems and machine learning and comes with 14 years of industry research and academic experience. He has published 15 research papers in international conferences and journals. He holds 3 patents in his name. Moreover, he serves as a review committee member for conferences of ACM and IEEE. Welcome to the show, Dr. Ankit. So you are currently quite established in industry and academic. Which one do you prefer more? Do you like the academic world or do you like the industry world?
That's a tricky question. I would say academic experience has helped me a lot in terms of building conceptually right things, and industry had taught me the first principle thinking. So both sides of coins has helped me a lot in my career.
Cool. That's quite interesting. And if you had to choose between one, where would you rather be?
Uh, at this point in time, I prefer to be in industry. It's more aggressive, it's more demanding, and at this age, I'm happy to take that challenge. And maybe at a later stage, when I want to be little more settled down or sort of something like that, I would probably choose an academic career.
Okay, that's quite interesting. So, how did you get into doing machine learning PhD? How did you? Was that a recent, you know, endeavor, or was it done much earlier, much before than the artificial intelligence boom that we saw a few years ago? How did you get into machine learning?
So my journey of machine learning, I would say it's a little bit old school. It started in 2007 when I graduated, and we had a course, simple like back then it wasn't so as machine learning. It was mainly around data mining, and we were studying that. I mean, as a subject, I studied it, but mostly I was fascinated about programming, and I was good at programming in Java back then. I helped few of my friends to implement their master's thesis into Java programming as I was into it, and they were coincidentally into data mining. So that got me an interest. Like,
Did,
let
did
me
you
just see if I,
did you
yeah.
charge them for doing their coursework?
Not really. Actually, it got me paid off in the later stage of my life when I could make good out of it, basically.
Makes sense. Yeah, that's so you have a really technical background. And obviously right now you are in a very senior position at Locus. So with that, um, what are the challenges you're facing at Locus and how do you solve them?
So, in general, I would say in data science, the biggest trouble right now is the scarcity of the talent. Like, there are a bunch of people, there are a bunch of aspirants for the data science, but there are a handful of people who really are really skilled at it. Uh, versus there are a bunch of people who has mastered the art of modeling, but data science is not only about modeling. Like, people, students these days do have misconception that if I know how to train a machine learning model, that makes my life easier. I mean, that is just like a drop in the ocean. You just do 10 to 20 percentage of the time that work. Most of your time spends into identifying the right data and putting it at a place so that you can build the model. And to break that mentality into the new bunch of incoming flow people, it's really a big challenge.
I have faced a similar challenge as well, or probably I would say the same. The funny thing is that I talk to a lot of people, and when I'm recruiting people as well, what they say is that we want to get into data science, and what they mean is that they want to be only tweaking models like on Kaggle, and that's it. And they're saying that we
Yeah,
like to do only the cool stuff, right? And then the data engineering part or any like software engineering part, that's not what we want to do. That's not cool. So
that's
I,
really
I
the problem.
really this yeah. And the thing is that what's really awkward is that Kaggle does not reflect real world. It does not reflect like a real world practice of how you do machine learning. That's the awkward thing.
Absolutely. I mean, there are a bunch of steps that you take before even you start modeling, and identifying the right thing to do itself is a challenge. Or I'll put it in a different way. Let me just try to elaborate a little more here. It's very important to understand for the beginners, especially, that data scientist also has to think beyond and out of the box in a way that you have to know how to deal with the blur requirement, or how to deal with the uncertainty, for example, or how to specifically deal with the ambiguities. Like, client
Yeah.
or maybe the product will come to you and will say that please try to build this algorithm or this model, but they really don't know, I mean, what they are asking for. You have to be very specific in asking the questions which are right enough to take out the answers that you want them to answer. So that is
Yeah.
the bigger challenge. Data science is beyond building the models. That's what I want to put across. You have to know how to deal with ambiguity, and you have to ask right questions to your stakeholders to reach to that stage.
Yeah. So one thing I would say is that I try to train people to basically look at how you could solve this problem without AI first. Because the thing is that a lot of the things that happen is that people start to say, okay, whatever the problem is, we will basically throw machine learning at it, and that's it. And the thing is that I'm thinking, no, 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 this is not how you solve a problem. Machine learning is a tool, modeling is a tool, but you have to first go and understand how you could have done this without machine learning, because that will actually give you like a way to think of this problem. How do you solve this without machine learning? If that is, more efficient, if that is a better approach, it could be that without machine learning, it might give you 99% accuracy. And with machine learning, it gives you 78. So, and
Yeah.
then with machine learning, you might actually have to train for like hours and hours, or in fact, sometimes days and days. So it's exactly the same thing where you have to tell people how to use machine learning as a tool. Yes, in some problems, it is the right answer. And in fact, what I would say is that before even going into machine learning, I would say that could you use someone else's model? Could you, there's so many APIs out there. There's DALI, there's, OpenAI's GPT, all sorts of Google Vision, Google Cloud Vision, all sorts of APIs out there. And they have done such great work. They've done so much work. It's like, if you could just use that, and if we can just integrate that, that's still, we can still say, you know what, tick box machine learning used.
Yeah, yeah, absolutely. I will go a little step back here and we'll start like this. Like, see, any AI projects per se starts with something which we call it as a rule-based learning. Like, you have some
Yeah.
if-else going on in your programs, and you have some business rules which you have set up as an if-else thing. And then eventually you collect a lot of data on top of it, and then you try to see if something can be learned out of it or not. I mean, it takes
Yeah.
years of efforts to reach that level where you can actually apply machine learning. I mean, it's not easy, it's not straightforward. That Having said that, I mean, there was a funny quote which I read somewhere that AI can always be present on slides, whereas in the backside, you might have some complex algorithm running, which is not an AI but a fancy thing.
Yeah.
Yeah.
So yeah, I agree. And so the thing is that it's the that is a huge challenge. So how do you solve that challenge? What would you say? Do you encounter that challenge in interviews as well?
Yeah, so twofold. One is your when you interview people, especially the people who are aspirants to the data science world, but they have not seen some real projects. They might have some myths about it. Maybe some, without offending anybody. I mean, just doing some Kaggle projects or some deep learning, .ai projects or something. They are not the real world, they are not mimicking the real world projects, especially because you have the ready-made data set, and that ready-made to reach to that stage of ready-made data set itself is a big deal, right? So if somebody provides you that, you're lucky. I mean, you have solved at least 70-80% of the problem. Coming back to your question, like educating the people that what is important part of the life cycle of a data science project itself takes a big challenge, not only to the data scientist or the aspirants, but also to the business stakeholders. They also have sometimes misconceptions that they have seen something in some competitor products or something where it is working. They don't know what's going on behind the scenes, and they will ask you to build something over the night as a magic stick. And probably, I mean, I'm not offending again anybody, but that's the way the world is moving, right? So everybody is quoting them that we are an AI first company or a data first company. I mean, how much they really use machine learning, that's a question mark. And to really do a machine learning on job, you require to have a specific skill set. I mean, it's not just about learning those decision tree algorithm or regression algorithm or some deep learning models. It's beyond that.
Yeah, so that reminds me of once I was reading a tender where they had this description, which was basically straight out of a sci-fi movie. What they were saying is that we'll have this one camera, and then from this one camera, we want to identify 50 people, and then we want to, I mean, counting is easy, but they didn't want to count. They want to actually name them. So with just one
Hmm.
camera, they're saying that just by looking at a bit of their face, you know what, identify their faces and name those people. And I was like, that's a very difficult task. Do you know how much what you actually require? And they were like, obviously it's like straight out of Marvel movie sort of thing. And I'm thinking, yeah, that's a very expensive. Just thinking about the calculation of what it would take to deliver that. I think it would, and the budget is obviously they have no idea of what it would actually cost. So it was really funny.
Yeah, absolutely. So this machine learning models, like the state of the art ones, the latest ones like GPT or beyond, has one thing which is very difficult to adopt them is the cost attached to it. It's not the training cost. Training cost is already imposed to the players who has already trained them, pre-trained them for us. Even fine tuning is costly for our own domain specific fine tuning. On top of it, you require inference cost. I mean, how many of the startups or even the mid-sized companies would have that budget to put in place the GPU servers to predict some variables, which are just one or two variables on their entire product dashboards, and may or may not be so useful to the customers, but just become fancy as an AI company. I mean, that's the question mark that I want to raise here.
Yeah, that is so true. That's why I propose, based on obviously, when I deal with certain clients, I first propose if we can use AI APIs where the we only have to pay for the inference cost and we have to keep it as low as possible, because then based on what their requirement is or based on their budget, we can say that whether it makes sense or not. And the other thing is that with any project, one thing we try to make sure is what that project will deliver. For example, if the data project will deliver an ROI of £500,000, right, or $500,000, but it actually costs 1 million, right? It makes no sense,
No
right?
sense.
But if it actually
Absolutely.
costs 100,000, right? It only costs 100,000, but it's going to deliver $500,000 back. Then it makes sense, right? So that is another thing where before embarking on a project, it makes sense to look at the ROI. Just look at the numbers, right? Do the numbers look right? And if they do, then yeah, let's do AI and investigate whether we need to build a model or do we use the APIs that are already available. So that's the sort of thing which I try to educate with my audience as well.
Sometimes it is difficult to the early stage startups to identify that what will be the uh, cost incurred when you use certain models. Maybe API based models are making that life much easier. However, let's say if you have built something of the self and if you have put it on the production recently, you don't know how much of the cost that you are paying. Maybe if it is a GPU based inference, it is even more, right? So I'm talking about something which is variable across the company, which is unseen and unforeseen, like suddenly increase in the
Yeah.
traffic of 10x may cost you suddenly 50x on your server cost. I mean, the last thing that you want to do is the variables which you have predicted. If it is not generating enough ROI, as you said, I mean, you would probably would like to drop that idea of becoming, the model-based prediction there.
Yeah, that is so true.
Yeah.
That basically brings me to the point of cloud cost optimization, because everything is happening on the cloud. And one thing we have to know, this is where normally, with interview questions, the big O notation question of how the algorithm scales. It's not no, normally if it's running on a local computer, it's okay. You don't care about it, right? If it's going to take a few seconds more. But when it comes to something on the cloud where it does impact everything, impacts the cost, that's where the big O notation, a graph that shows if something is going to scale exponentially or it's going to scale linearly or it may not scale at all. That's really relevant here, where we can see, what is the actual full cost of all the algorithms of all the systems running, and then let's put it on a graph and see how does it scale. So that's exactly the sort of point on does it actually make sense to train our own model and then put it on the cloud, GPU based inference, and how big is the GPU? That's another thing as well. So yeah, that's a great point where we have
I w-
to look at the cloud costs basically.
I would add one point here, which is very much relevant to the Locus specifically, or Locus or similar companies which are solving similar problems. Is we are into optimization, last mile deliveries. So we create routes, and the parent problem is the CVRP, whereas the child problem is the TSP problem that we are solving. Now, as a nature, they are the NP hard problems, and as the NP hard says itself, that they are unsolvable problem, even if you throw infinite compute to them. Uh, as the number of locations increases, the amount of time taken to find the optimal solution increases exponentially. Now, imagine who better than us can tell you the server cost on that, because we are
Hmm.
running into optimization day on day, and the only thing that we are worried about is that how can we solve NP hard problem using something magical which can save our server cost. Because in optimization, what exactly you do, you have a search space, you have a huge search space, and you try to either prune the search space, or you have to iteratively visit each and every solutions in the search space, and you have to figure out which one is the better one, right? And doing it for as large number of nodes as you have in the network, it becomes the costly affair.
Yeah, that is true. So How so that's a really interesting problem. That's really sort of interesting scenario. So one thing I've come across with Google, with the classic problem of classifying between a cat and a dog, right? Is it a cat or a dog? A machine learning problem. Now that's everyone does that, but then Google took it further, where they try to break down and identify the different breeds of cats and dogs, because
Hmm.
some cats and
Yeah,
dogs breeds might look actually quite similar.
yeah,
So with that, the way they've done it is that they've done it in scales, in stages. So first stage of machine learning algorithm will try to predict if it's a cat or a dog, right? The second machine learning model will try to predict if it's a class of this breed or classes of another breed, and then you break it down further into different breeds and break it down even further of maybe regions as well. And so that's how they go and break it down. So could you not do something similar where you with obviously your basically the problems you're facing is that traveling salesman problem, right? Finding
yeah,
the optimal route. Now,
yeah,
could you not the group the different locations together based on if they are too near each other? If they are, like, say, within 5 miles of each other, you group that like cluster together, and then group another cluster together, and then another cluster together, and so then you have only 5 clusters to first solve a problem, and then you have once you solved it for 5 clusters, then you say, okay, fine, for each cluster we solve it again. What would you
yeah,
say
yeah.
to that? How would that work?
So at a high level, yeah, that is how the problems in the industry are, as a SOTA solution is being solved. However, there are challenges because these are not simple traveling salesman problems. There are constraints attached to it. I mean, if you will go
Yeah.
and see the literature in the, scholar or something, you will find that these problems are nicely solved problems. However, when it comes to the reality, when it comes to the real constraints, real world constraints, it becomes much more difficult problems to solve. I'll give you a few examples of the constraints. Like, for example, uh, your client might demand that my drivers should not exceed their time limit even by 1 minute. Their shift starts from 9 a.m. and that ends at 5 p.m., then that has to be respected as is. Or, on the other hand, the client will also say that the driver should not be idle for 5 minutes extra. So you have to accommodate all the tasks to the driver, which are exactly fitting into his schedule. On the other hand, you also have to take care about the real life traffic conditions, the weather conditions, the on ground situations, the accidents might happen on ground, and so on and so forth. There are roughly 250 constraints that you are seeing while you are building a short trip towards for a driver. I mean, imagine doing it for all the clients and so providing it as a SaaS solution. Sorry, so providing it as a PaaS solution to the all the clients as an same underlying algorithm. That's the real challenge that we are solving.
That's a really interesting one. That reminds me of Google Maps in their early days, when they used to obviously get quite a lot of predictions wrong, right? But over the years, because so many people were using Google Maps, they were collecting all of that data on the road from their phones, and then obviously improved Google Maps, predictability so much that it's right down to accuracy of like 1 minute, that it knows if there is a traffic jam, obviously based on other phones and so on. So it's quite a interesting problem, basically. And it has taken Google years and years and years and so many devices. So it's a challenge that it has taken them such a long time. So yeah, I can imagine.
So the thing is that that particular business is dominated by Google. There are solutions here
Yeah.
and there which you might encounter. However, the best of the available solutions are available only at Google Maps. The problem with that is one is, of course, the cost because it's dominating the market. Second is that even though they have collected the data over the years and years, even though they have their presence for many of the countries or many of the parts of the world, there are parts of the world where their accuracies are not so good. For example, Southeast Asia, the densely crowded area, the streets are very narrow, and so on and so forth. Like people might cross the road even if it is not allowed to be crossed. So algorithm will learn something which is not allowed to be learned, right? Breaking the traffic rules. So a driver delivering something in while traveling into the opposite lane, algorithm doesn't know that, and that has resulted into the wrong learning over the time, and that has fed back into the algorithm. This has led to some misprediction of the ETAs. So these things are still to be figured out, and to do it right, there are better things available. But the thing is that this problem will persist for a long time unless those ground level realities are sorted out.
Yeah, and the thing is that companies such as Locus has an opportunity here because obviously Google will probably not optimize for the local situation in different
Yes.
regions, be it India or even South America or some parts of Africa. The thing is that those are quite local sort of problems. And then the other thing is that obviously there are other companies, other maps companies out there. For example, Ordnance Survey in the UK, they have better maps, but then there is no sort of navigation ability on Ordnance Survey. Uh,
Yep.
and whereas you could then use the Ordnance Survey maps, but then the navigation is something you have to do yourself from the API. But so that's basically it. Where there might be some maps companies which are better in their local customization, but then you have to do certain amount of navigation on how it will work and predict that. So yeah.
So, answer to that, a short answer, maybe it's a little perception on my side, is no single organization has consolidated view or the data across the logistics segment. And that's the bigger
Hmm.
challenge. And that becomes an opportunity for a lot of map companies, probably. That if you have the consolidated view of the data across the logistics segment, probably that can help companies like Locus to focus on the focused problems which are optimizing the last mile deliveries versus solving for the maps.
Yeah. Yeah. So that's quite interesting. So what would you advocate? What is one thing you would like to see in the software or IT and or data world that isn't happening right now?
Okay, so I would not go too broader in my advocacy here. I would stick to the constraints that I have seen in my day-to-day challenges is providing the data democratized access to the right people at right time to make right decisions versus balancing it out to the data privacy and access control. This has become a very nuanced challenge, especially for the past companies. And I don't know, I mean, there is no solution and there is no right answer or wrong answer to this, but there are ways in which we are moving on. And there are data policies and uh, uh, data architectures that we are developing, which will help us eventually solve this problem in a longer run, right? In
So
the
that's
second
quite
one,
interesting. Yeah, it's
in the
go on.
second one, I also want to add further that I always inspire or I always ask people to make decisions not based on the intuitions, but always driven by data-backed arguments, right? So to do that, also you require to do the data democratization.
So yeah, that's quite interesting. And I can imagine there's obviously a lot of companies hold the data, but they don't open it up. In fact, what's really bad is that sometimes they don't open up. One department doesn't open up to another department within the same company.
Yeah,
They're
yeah,
competing. Different departments are competing. So yeah,
yeah.
it's quite a challenge. Yeah.
and to build and see if you have this, imagine that you have this ability, and if you have access and democratized data access to all the people, right access to right people. I'm not saying every data access should be given to every people, but to a limit, to an extent, you can provide access to make right decisions. Now imagine that you have this layer sorted out. Then what you can do beyond that is that you can have a platform which is driven by insights, which are not only insights but actionable insights to your customers or to your own product building, which can help you to build the products or take the decisions at the client side, which are descriptive analytics or maybe diagnostic analytics or prescriptive analysis, or maybe the predictive analytics. All sorts of analytics you can do if you have this first layer sorted out.
Hmm. Cool. Yeah, that's good. That's quite interesting. Um, that's quite interesting. And which within with your with Locus, which technologies do you use? Um, Obviously, machine learning, but are you focused on Python or um, which technologies do you use?
So initially we were, a little bit free on our take to choose the language. However, as the code base has increased in the number of lines, and there are some challenges into, freely allowing people to choose the language, we had to take a hard call of staying stick to the Python as a language, especially for the data science side. For the backend, it's different, but for the data science, it's purely Python that we have made as a final choice for now. We might change it in future depending upon the need, but right now it is going to be Python for at least a couple of years down the line.
Yeah, so same here. The thing is that the way I advocate Python is that if we stick to Python and we stick to, say, 3.8 Python, the great thing is that we will have less errors, and we will have whatever errors we have, they will be all the same, right? So it's like you reduce the number of bugs that you need to solve, because if someone else has solved it, then you'll know that's how you solve it, and you don't have to waste time on solving bugs that don't need to be solved. So that's
Yep.
basically I advocate the same, where it's better to stick to one language across the whole company, basically.
Yeah, I mean it was a hard call back then to take. Now we have realized it was a good decision. Over the time it has been proven. Other than that, I mean, language is just one thing that you do for choice of technology. There are so many other aspects like choice of databases, choice of architectures that you build, and so on and so forth. I would go one step deeper here and will say that although we have chosen Python as a programming language, there is one thing which I would like to call out is we write Python code as if it's a C code or C++ code, to be specific. It's that low level code. So although our Python code is, I mean, as a language, it is written in a high level programming language. Uh, it has given us a boost of almost 10x from our previous version of the algorithm, just because we are writing it as a low level code.
That's quite interesting. And I guess you have sort of enforced the whole company to write it in that way, so that all the code that's running is as efficient as possible.
Yeah, there are two parameters that we track here. One is, of course, the scalability of the algorithm, and second is the speed at which you can produce the output. So both of them has paid us off in terms of the performance and scale.
That's quite interesting. That's the first time I'm hearing about Python being used in that way, but it makes sense. Yeah, it makes sense. Which cloud technology do you use? Which cloud platform?
So we are onto Amazon's, but AWS, but we are almost cloud agnostic. If we have to switch, we are not so tightly coupled with the cloud. We can move to any cloud basically. One more point
Nice. Cool.
I
That's
would
great.
like to mention before to the question which you raised before, the Python as a programming language is uh, although we have written it into Python, the reason of choice of Python was always debatable when we had to take that decision. So the argument which I heard from the tech lead in the team was very interesting. Like this development speed is increasing if you choose a Python kind of a language versus if you choose a C kind of a language. And that was the turning point to decision that how do we decide between Python or Java or Python or C++.
Okay. Yeah, that's quite interesting. It's a very interesting way of looking at it because Python is it makes it easier because it makes it much easier to understand. There's more support available, and then if you want to write it in a way that is low level, where you take care of each step and which algorithm is doing what, that's very much possible with Python, and that's so it makes sense from that perspective that you use Python to do that. Obviously, you could use Scala or Java, but it's just that with Scala, what I found is that there's less support available, and what happens is you have to then become a full expert of Scala. It's a bit like you have to then become a full expert of C++ to find the most optimal algorithm to do something. Whereas it's much easier to become a full expert of Python because there's so much support available. And then obviously you can keep the algorithms to as optimized way as possible. And it's much easier to do that across the whole company. And, the whole company's productivity is much higher.
Absolutely. Just adding one last thought to this is you if you want to find a developer of Scala versus a developer of Python, as a manager, I would
Yeah.
prefer to opt for the finding the developer of Python. Although optimization is a niche skill, writing the optimization code in Python is at least relatively less niche. I don't want to go with Scala optimization. That will make my life miserable.
Yeah, I agree. So the thing is that's another point on which I actually mention. I advocate the same point with my clients that it's going to be much difficult to find a developer for Scala. And then the other thing is that you don't. It's not just you need a developer; you need a development team because the thing is that
Yeah,
one person has written Scala. How do you know that's the most efficient, right? And
yeah.
then you have to study that code as well, and then someone else has to study that code, and then if one person leaves, then there's only one person who's doing that. So it's very scary.
Yeah, absolutely. As a manager, that would be the last thing that I would do.
Yeah, and then the awkward thing is that with Scala, with obviously when using Scala, you often end up using Spark as well. The
Yeah,
awkward thing is that the way the code is written is so unconventional. Compared to Java, compared to Python, compared to C sharp, it's so unconventional. It's like you would never think this is how you would write this, bit of code. It's just really weird.
I would say choice of Scala becomes obvious if you have to do big data processing using Spark. If that is the route that I have
Yeah.
to take, then probably I will choose Scala as a programming language. Or uh, why not PySpark? To advocate that, what I would add is see, there are some features which are specifically released in Scala in Spark versus not released ever into PySpark, maybe due to some implementation limitations of Python or short. So if you are using those niche features of Scala Spark, then only I would advocate to use Scala as a programming language, especially when you are writing ETL jobs into the Spark.
Yeah. So we yeah. So there was this. I worked with the Ordnance Survey, and Ordnance Survey was doing Spark basically in Scala. And the thing is that they obviously have big data, and they had a huge team to take care of their Scala code because everyone was doing Scala, and that just makes sense because obviously if one person gets it wrong, then another person is there, and they have a huge team to take care of that. So it makes sense for them. And also the other aspect is that with PySpark, that's then still using it's not native, because obviously Spark
Yeah,
is native to Java Virtual Machine, which is
yeah,
natural or
yeah.
native to Scala. So it makes
Yeah,
sense, but it's not native to Python.
Python.
So in that sense, if you are using exactly, if you're using big data and you have like trillions of rows of data, or terabytes and terabytes, then yes, of course, it makes sense to use Scala. But for something smaller or for a small company, it makes sense to stick with Python to make sure that you are competitive with a larger company.
Yeah, absolutely agree on that.
Cool. So thank you for being on the podcast. On in the end, I would mention that Locus has been identified by Gartner as a top vendor in its market guide for vehicle routing and scheduling and last mile technologies. The link will be in the podcast, in the video below. And the second thing I would mention is that visit locus.sh for any of your supply chain and logistics problem discussions and solutions. Thanks so much for being on the show, Ankit.
Thank you. Thank you for hosting, Jen.